A radioactive atom begins to decay. It emits an alpha particle and a beta particle. Gamma radiation and energy are also released. Electromagnetic force originates from the electric charge of particles. The strong nuclear force is an attractive force that holds the nucleus together. Alpha radiation is stopped by paper. Beta radiation is stopped by perspex. Gamma radiation is stopped by lead. You arrange radioactive emissions from the one with least frequency to the one with high frequency. Same for wavelength in tabular form. Here are the three isotopes of carbon. Carbon-14. Carbon-14 is the radioactive isotope used in carbon dating. Penetrating power is inversely related to the mass of the emission. Lighter particles travel faster and penetrate further than heavier ones. Gamma ray is the high-energy electromagnetic radiation. It has the shortest wavelength and the highest frequency.
The most radioactive element is polonium-210. The most concentrated sources are in Kazakhstan, Canada, and Australia.
The nucleus of a radioactive atom disintegrates due to an imbalance. Electrostatic repulsion overcomes the strong nuclear force. This causes the atom to decay. The nucleus is held by the strong nuclear force, but the electrostatic force between balance causes repulsion.
Strong nuclear force binds protons and neutrons in the atom's nucleus. Beta involves the weak force, emitting electrons and neutrinos. Observe the Geiger counter. Now, I place the alpha source behind this paper. The reading barely changes. Alpha particles are stopped by the paper. They are easily blocked. Observe the Geiger counter as I bring the source close.
Precisely. Beta particles are more penetrating than alpha.
And they are lighter? Welcome, students. Today we'll see how gamma rays penetrate matter.
How can we observe that?
With this Geiger counter, watch the reading rise. Gamma rays originate from nuclear decay.
From the nucleus?
Yes, during transitions to lower energy.
Ah, I see.
Gamma rays come from the nucleus. What particles are involved?
Is it electrons and protons?
No, it's neutrons and protons. Welcome. Let's arrange alpha, beta, and gamma by penetrating power.
Alpha is first, stopped by skin.
And gamma is most penetrating.
From most to least penetrating power, gamma radiation has the highest penetrating power, followed by beta particles, and alpha particles have lowest.
Welcome, students from every continent. Today, where unstable nucleus emits particles, alpha, beta, or gamma rays, changing the atom. The decay of a radioactive element is given by the formula N of T equals N0 times E to the negative alpha T, where N0 is the initial quantity. Half-life is the time it takes for a radioactive substance to decay to half its amount. It's related to the decay constant Gaussian divided by half-life. Alpha particles have important industrial applications.
Like in smoke detectors, right?
Exactly. They also power some spacecraft. Today, we'll explore industrial uses of beta particles.
Can you give an example?
Yes, they are used for measuring material thickness, like in paper production. Welcome to the Radioactivity Lab. Today, we'll see uses of gamma and electromagnetic radiation. Exactly. Let's look at a Geiger counter.
Carbon dating determines an object's age by measuring its carbon-14 content. It's used for artifacts and samples up to 50,000 years old.